All right, so it says which function has the same end behavior as x approaches infinity as the function graphed here. So f of x is some sort of variation. I probably should change that to like g of x. F of x is some variation of what we call a rational expression or a rational. You can't really call it a function. Yeah, you can't really call it a function, but it's more of a rational expression. So, I mean, you can. It's just the domain has to be defined. So, anyways, when they're talking about as x approaches infinity, what they want us to consider is what happens when this line goes on forever. Okay? And I'm going to erase this because this might confuse some people because I'm jumping ahead. We're really just going to focus on what does this mean? So as this goes on and on forever and an x approaches positive infinity, we just imagine that this thing goes on forever that way. One of these graphs will do the same thing, okay? Now these are exponential functions, but most exponential functions will curl up, or if they have a negative sign in front of them, they'll curl down. So that doesn't really change a whole lot, other than sometimes they'll go this way and sometimes they'll go this way. So depending on the graph, in other words, going to the right on the graph may change based on the graph with these exponential functions. So we really have to graph them. And what does this mean? Well, if I look at this number, so there's 1, 2, 3, 4, 5 marks till you get to 2. Okay, so this looks like this is 3 out of 5 times 2, so 2 times 3/5 is 6/5. Actually, no, we need to do that the other way. It's 10/3. So I'm trying to figure out what 3/5 of 2 is, and so it'd be 5/3. Because when you divide by a fraction, you multiply by the reciprocal. No, it can't be 10/3. It was 6/5. That's what it was. I did it right. It's Monday. All right. So what I'm trying to do is figure out what it approaches. So what I'm going to do, I'm trying to figure out what this little mark is because this is a vertical asymptote. This line is going to curve, but it's never really going to cross this vertical asymptote. So I'm really trying to determine what this value is. That value is 3/5 of 2, right? Because it's 1, 2, 3 marks, but there's 5 divisions among from 0 to 2. So I do just multiply it out, which is 6/5, which on a calculator would be 1.2, I think, approximately. All right, so what I need to do is I need to graph one of these functions and see which one will approach 1.2. All right, so let's just graph the first one. I think it's the first one. I don't think it's this one because that negative sign's gonna flip the exponential, but we'll see. The truth is we just gotta graph it. And if it looks like it's approaching 1.2, but not crossing like 1.2, then that's how we'll know. So I'm just gonna open up this calculator. Hopefully sometime today it'll open. It's going a little slow for some reason. I could graph this in Desmos just for the fun of it. Dang it. So our first function is 4 times the quantity 0.5 raised to the x, I believe it was plus 3, right? Let's double check that. Yeah. So now if I zoom out on this, when we talk about going to infinity, we're talking about what does this thing do as we keep going on and on and on. I'm going to point on this and try and get a value. That seems to point towards 3. So that asymptote appears to point to 3. So let me reread this question. It says, which function has the same end behavior as the one graphed here? Interesting. Well, this one seems to be approaching 1.2. This one seems to be approaching 0.3. I don't, among all the choices, that's the closest one though. So let me double check my answer. This one's 0.2, but the behavior this one will approach 3 sort of, but it's not quite the same end behavior. But let's graph the second one just in case. So the next one was -2 2 raised to the x, and then +3. I'm just going to graph them all. Okay. The next one was 2. Oops, not s. This is 3. 2 raised to the 3 raised to the x -3. I'm a little stumped. I'm very confident about A. So sometimes these questions are not the most clear on which is the correct answer, which is part of real life. Like if you take the SAT, the SAT will have an answer. You got to choose the one that's the closest, and unfortunately, you got to look at all of them. All right, so here we are. Let me zoom out. So we're looking at the end behavior. So I'm going to start with so this is the last function. This is option D. That's not it. All right. This is option C. That's not it. This is option B. That's not it. This is option A. It doesn't approach 1.2, but it's the only end behavior that's similar to the one in the question that we have. So I'm going to go with A just because it's similar. So if I were the person writing this test, I wouldn't say same, I would say similar. Because same implies that they have the same vertical asymptote. Which you could have if they switch that value to 1.2. In other words, if I were to do this, if I were to change this to 1.2, now when I click on this, guess what? See how those values are 1.2? So anyways, the correct answer is A. So we're going to choose A. Obviously, if you're bubbling in a bubble sheet, you need to do a lot better than that.